Okay, so that's generally kind of where we left it on Wednesday. So let's do another problem. Okay, so if we were going to diagram this, and it's diagrammed on the next slide, but just to kind of show you how you lift out, you can lift out words and turn them into kind of a diagram strategy. You know, how many inches, question mark inches, is 5.52 centimeters. Okay, so we need an equivalency statement between inches and centimeters, and that was the one you're supposed to memorize, right? So to work this diagrammed, it looks like this, where over what we want to accomplish, we can put the equivalency statement, the exact relationship that there are 2.54 centimeters exactly in 1 inch. Okay, so that equivalency statement, we're going to use it as a ratio here in a minute, okay, and we want centimeters to cancel. So now working the problem, I always put the thing that you want to convert over 1, okay, so 5.52 centimeters over 1. And so I want centimeters to cancel, so it looks like I'm going to put 2.54 centimeters in the denominator of the next term. That's just it. Okay, 1 inch over 2.54 centimeters. So centimeters will cancel, and we're left with units of inches. So it's all about letting your units do the work. And then you go ahead and get your calculator out and do the division. So fingers ready? How many sig figs are we going to round it to? Yep, I'm liking it. Very good. Perfect. 2.17 inches, okay, is the conversion, or is equal to 5.52 centimeters. Yeah. So Google is really good about this one. It's not good about some other things, but if you just say, and some of us can talk to our computers, but if you just say, to go to Google and say, convert 5.52 centimeters to inches, it will do it. It will spit back 2.17 inches. But you have to, that won't be good enough for us, because you have to show the work just like that. So on all the assignments and all your exams, it says use the factor label method. That's what it's talking about, okay? So let's do another one. So question mark grams are going to go over to the right. What we're starting with is 2.75 ounces. So it looks like this, okay? Now, on your, let's see, at the beginning of this part, we're on part 4, right? At the beginning of this part, there was a slide that had actually related pounds to grams. Now, you don't have to memorize that. I just mentioned that because it's possible that you have the pounds to grams, but you don't have the ounces to grams. So in this case, we can go from ounces to pounds and then pounds to grams. So it's like a two sort of thing, okay? You got to kind of go with what you have to work with. So the relationship between ounces and pounds in the English system, it's an exact relationship, is 1 pound is exactly equal to 16 ounces. And then this one right here, the relationship between grams and pounds, you don't have to memorize. But you need to know how to go about finding it to work problems. So your textbook, and I see Logan's got his out. Can I borrow your textbook?
Yeah.
So if you go back to this last page, no, it's not even a page, inside this cover, there are some really helpful things here. Each textbook's a little bit different, but these can be very, especially these 2 boxes. Thanks. All right. So the first thing is always going to be the thing we want to convert, so it's the number of ounces over 1. Then we want to get rid of our ounces and go to pounds. So you see where I'm going to put 16 ounces in the bottom and 1 pound in the top. Okay. So now ounces have canceled. If I stop the problem, I got units of pounds. But I want units of grams. So then I'm going to turn, or we're going to, or whoever's working this problem, is going to turn their attention to this equality and plug it in here to make pounds cancel. So we're going to put 1 pound on the bottom, 453.6 grams on the top. So now, unit-wise, notice the ounces have canceled, the pounds have canceled, we're left with units of grams. And again, you know, if the units work out how you have your problem set up, put another way, you are just perfect. So now, as far as rounding, okay, we said that there's uncertainty in all measured quantities. Do you guys see where there's no uncertainty in this 1 or the 16? Because it's by definition. Now, when somebody gives you an equality like this one, okay, they mean that in exactly 1 pound, there is approximately 453.6 grams. So actually, these 4 sig figs do govern potentially how you need to round. Does that make sense? Okay. So we don't do anything with this 1, but we count 4 sig figs there. So get your fingers ready. How many sig figs do we need to round it to? Yeah. Oh, yep, very good. Perfect. Okay, so here we go. Plug in your calculator and hopefully you got that one. 78.0 grams. Okay? We could do these all day. All right, another one, okay? Sometimes it helps to kind of take a bird's eye view and look, are you English, are you metric? Okay, so milliliters is metric, cups is English, right? Now, if you look back on that little box thing, I'm pretty sure you had one between quarts and liters. It's kind of a common.
Gallons and liters.
Gallons and liters, thank you. What page is that on, Cameron?
It looks like page 1.
Oh, page 1?
Yeah,
For
but
this,
it's like not on page 1 of like this section.
page 1
Page
of
one,
part
4.
Part 4, page 1. Part 4, page 1. Okay. Yeah. So we have, and likely I would give you, you don't have to memorize it for sure, I know that. But I might need to give that to you on a test. So we have, would you say liters and gallons?
Yep.
Okay. So we have liters and gallons. So we kind of have to fill in the blanks there a little bit. Or else look on the internet, look for the equivalency statement between cups and milliliters, which is kind of defeating the purpose for some of these problems. Okay, so we're going to go from milliliters to cups. So we can get to liters. Okay, not too bad. Okay. And once we get from milliliters to liters, we can get from liters to gallons using that one that's on the box there. In the box it says 1 gallon is approximately equal to, that's what you say, 3.785 liters. 1 gallon is approximately equal to 3.785 liters. So then we simply had to fill in the blanks. We know the relationship between, there's 1,000 milliliters in a liter, right? Now, if you're like me, I would have to think through it for a little while. How many cups are in a gallon? I just click this button and it tells me. It confuses me. On a test, I wouldn't ever have you do that. But, so there are, because you go pints, right? There are 2 cups in a pint, and there are 2 pints in a quart, and there are 4 quarts in a gallon, that sort of thing. Okay. Or 16 cups. That's exact, right? So setting this up to work it, the first term's going to be the milliliters, that 275 milliliters over 1 that we want to convert. Then we want milliliters to cancel, so we're going to put 1 liter over 1,000 milliliters for the next term. And milliliters will cancel. And then we want liters to cancel, so we'll put 1 gallon, oh, sorry, yeah. We want liters to cancel, we'll put 1 gallon over 3.785 liters. And then we want gallons to cancel, so we'll put 16 cups over 1 gallon. Is that right? So then this is my funnest, I think this is the best part of this. So then you go canceling milliliters, canceling liters, canceling gallons. Okay, and you're left with cups, which is where you want to be. So as far as rounding goes, let's see, definitely, and since we're multiplying / dividing, we're going to count sig figs. So I got 3 sig figs over here, okay. I don't count any uncertainty in the 1 or the 1,000 because there's no uncertainty introduced. Down here, the 1 gallon over 3.785 liters, okay. The 1 in the gallon, nothing, but definitely the 3.785, that brings 4 sig figs, okay. And then the last one's by definition, so I don't have to count that one. So I got 4 and 3, so I'm going to round to 3. So 1.16 cups. So conversions, right? So we're going to work this one 2 ways. This is a distance one. We're going to convert from miles to kilometers the easy way first. This would be on the inside of your, inside your book, inside the cover of your book. The equivalency, the direct equivalency. So if I want to go from miles to kilometers, okay, you would look this up on a table, okay. 1 mile is approximately equal to 1.609 kilometers. So this conversion is not too bad. A catch with this problem, though, is did you catch that in the paragraph it was 120 with a decimal after the 0? Okay, so one of the things, working problems don't blow off that important information. So that's the number we're converting, 120 miles with 3 sig figs. And we want miles to cancel, so it looks like we're going to put 1.609 kilometers over 1 mile. Then miles will cancel, and you're done. So it looks like, how many sig figs? Let's see your hands up. How many sig figs do we need to round it to? Yep, I got my fingers right this time. Okay, so 120 miles with 3 sig figs is 193 kilometers. Not too bad. But let's just say you didn't have that equality. The 1 mile is equal to 1.609 kilometers. Let's say you didn't have that. The one thing I am having you memorize is between the English and the metric system is that whole 1 inch is exactly equal to 2.54 centimeters. We could actually build, and that's the second way to do this. I know you're like, what? We could actually, and it's called the indirect solution to the same 120 miles problem, but we could go through that. Okay? So whenever you go from, in this case, English to metric, or if you go from metric to English, isn't this almost poetic? You are crossing the imperial bridge. Right. Metric imperial bridge. All right, so what does it look like leading up to that? Well, leading up to that, and you may not, I don't always remember this number, but you guys remember how many feet in a mile?
2,000, 5,000.
I heard it, yeah, 5,280, exactly. And no pun intended, it really is exact. So, okay, there are exactly 5,280 feet in 1 mile, by definition. Whew. Of course, there are 12 inches in 1 foot, right? That's pretty good. Now we're on our way to kilometers from centimeters now, right? So I really go through the base unit. Of course, the base unit being meters. I go centimeters to meters and meters to kilometers. I do. Some people are fancy. They can go straight from centimeters to kilometers. Okay, so there are 1 meter is equal to 100 centimeters. Very good. Almost done. With regard to meters to kilometers, we know that 1 kilometer is equal to 1,000 meters. Phew. The roundabout. So just like we did before, the thing we want to convert is going to be our first term, that 120 miles with 3 sig figs. So don't forget the decimal after the 0. Then we want miles to cancel, so we'll go 5,280 feet over 1 mile. And then we want feet to cancel, so we'll go 12 inches over 1 foot. And then we want inches to cancel, so we'll go 2.54 centimeters over 1 inch. That's our fourth term, 2.54 centimeters over 1 inch. And then we want centimeters to cancel, so we'll go 1 meter over 100 centimeters. And then we want meters to cancel, so we'll go 1 kilometer over 1,000 meters. Dang. So parts is parts. Oops. So miles have canceled, feet have canceled, inches have canceled, centimeters have canceled, meters have canceled, and you're left with units of kilometers. Woohoo! So where I put a check mark, that's uncertainty in the first term, 3 sig figs. No uncertainty brought by the second ratio. No uncertainty brought by the third ratio. Wow. No uncertainty brought by the fourth. No uncertainty brought by the fifth. No uncertainty brought by the sixth. Those are all exact. So 3 sig figs. 193 kilometers. What did we get with the last one? Is it different? 193. Okay, I couldn't remember. It's like, oh, is it different? Well, not. But sometimes it will be different if you have slightly different conversion factors. Any questions about that? Okay. Whew. Switching gears a little bit. Okay. Now, this is not an equality that we're going to use here, but we are definitely going to use the factor label method of working a problem. Anytime you have a physical property like density, in this case speed, it could be anything, that oftentimes can be used as a conversion factor. So for instance, we have a bird that's flying pretty darn fast, I think, 14 meters in 1 second. I'm just saying, right? It's booking. I don't know if that's right, but anyway, our loon is flying 14 meters per second. So that's kind of physical property of the loon. And actually, we can use speed to go back and forth between these 2 units. Okay? We can get meters if we have seconds. We can get seconds if we have meters. I'll show you how that works, but just in general. So the question here is, if we were going to diagram it, kind of like we have been, bless you.
Excuse me.
How long will it take? So question mark, time. How long will it take for the loon to fly 5.00 kilometers? So that's what we have to deal with. So we're going to 5.00 kilometers to time, basically. So to work this, I've talked about the term unpack, and here it comes again. You need to unpack that speed. The 14m/s, what that means is 14 meters in 1 second. We could still also say for that loon that in 1 second it will fly 14 meters. So those two are related to each other, those ratios by the inverse of each other, right? We could also flatten it out, and again, it's just a particular property of this particular loon. We could say for this loon, I know it's weird to think that time is equal to a distance, but 1 second is equal to 14 meters. So if you want to, that's our equality to deal with. So it's kind of like we've been working problems before, though. So we're going to go from the kilometers, that 5.00 kilometers. Notice one of the things we're going to have to fix is we need to get it into meters because our speed is in meters. So right off the bat, we've got to fix that. Of course, we know we can fix that. There's, what, 1 kilometer is equal to 1,000 meters. So new to this problem now we can go from meters to seconds, okay, using the property of the loon. So that second blue statement up there, that is the velocity. And actually, we're done then. I'll just put speed. I guess it doesn't really give direction, so it's really just speed. You've got to be careful. Sometimes it says, how long will it take the loon to fly 5.00 kilometers? Give the time in minutes, okay? So just don't let that throw you off. Oh, does it say in minutes? Oh, drat. Pay attention. So now we need to get the time into minutes, and of course you guys are good with that. 1 minute is exactly equal to 60 seconds. Very good. Okay, so the game plan is to start with our 5.00 kilometers over 1. We have to have kilometers cancel, be left with meters, so the next term is going to be 1,000 meters over 1 kilometer. And then here's where now we want meters to cancel and be left with seconds, so we're going to put 1 second over 14 meters. So here's then one last thing to clean it up to get time into minutes. We want seconds to cancel when we're left with minutes, so put 1 minute over 60 seconds. And then you should be able to go check, have your stuff cancel, the units cancel, kilometers cancel, meters cancel, seconds cancel, and you're left with units of minutes, which is what we're supposed to have. So, of course, there's uncertainty here in the initial distance. No uncertainty brought within the metric system. There is uncertainty here. Okay? And this is kind of like that other qualities that we dealt with. There's no uncertainty with the 1 second, but the 14 meters is approximate. And, of course, that last one, there's no. So, how many significant figures do we need? 2. Yep. 6.0 minutes. Okay, so again, if you have something like speed like this, and you want to know what you can use it to convert back and forth, look at the units of that thing, and that's what you can go back and forth between. Okay. So I'm going to take a look at these. These will be due on Monday. Okay? So we'll kind of look at them. Don't forget that what I'm going to show you here in a minute, I actually am going to post as a PDF. I'm going to, on the Twitter feed. So if you're like, what? Ask me. But these actually are available, kind of like they were before. Maybe. Conversions. Okay. So here's 27 and 28. So for instance, 27C I picked on purpose. Maybe I didn't. 27C is within the metric system, cubic centimeters to milliliters. And I just kind of showed you, I didn't put over the arrow how to accomplish that, but I kind of said, and you know, you guys know this. You know, set cubic centimeters, we know that there's 1 milliliter, 1 cubic centimeter. But I don't want you just to say they're equal. For instance, this is how I would set up the problem. Of course, I would put 1 milliliter, 1 cubic centimeter there. Okay, that's the hints for that one. Oops, I knew I was going to do that. It only does what I ask it to do. Okay. Now, there we go. And so actually for 27, I also picked on D for a reason. We're going to on Monday kind of talk about the whole cubing something. But for D, notice you're within the metric system, but you're supposed to go from meters cubed to centimeters cubed. Okay, now you guys know that there's a relationship of 1 meter to 100 centimeters. I bet you're good with that. But if you are talking about 1 cubic meter to 100 centimeters cubed, you have to basically, and again, I'm not a math teacher, I'm not a statistician, okay, but you have to, for this one, oh yeah, I went ahead and did it. You have to take the cube into the number, which is 100. So 100 cubed actually is this number, 100 cubed. So it's like 1 with 6 zeros after it. Okay. You have to take the cube into the number and the units. So that's my hint for that one. We'll talk more about that on Monday. I went ahead and gave you a hint for our 28C. So 28C is an example. I know it seems roundabout, and some of you would say, well, there's a factor of 10 between millimeters and centimeters, and you'd be right. But notice to work it, what I did is I would convert from millimeters to meters and then meters back to centimeters. So you're okay if you go directly from millimeters to centimeters, but I would go through the base unit. It's just less likely to be wrong. And sometimes the stakes are higher than others. Okay, so 33, 34, and 35, I don't have any builds here. It's all at once. But 33 is kind of up in this upper right-hand corner up here. Notice all I did for 33 is they are introducing a new unit of length called a hand. And when you read that a few times, it just simply says that 1 hand is exactly equal to 4 inches. It's a new unit of length. So then in blue there, I kind of have how I would go about going from hands to meters. Again, some of these hints you're like, you guys would have gotten it, but they're there if you want them. Question 34, again, a new unit of length. It's a furlong, okay? If you read 34, it tells you that there are 8 furlongs. It's exactly equal to 1 mile. And then there's a new unit of length called a chain. 10 chains is equal to 1 furlong. All these things over here, these equivalencies, I just pulled them out of the question. Okay? Then there's a link. 100 links is equal to 1 chain. So down here for 34, my hint is to start with 1.00 links and go all the way to centimeters. I know. Is that not fun or what? Okay. 35, it's kind of a speed sort of problem. And so I went ahead and it says that this person can go 100 yards in 9.3 seconds and then asks an assortment of questions. So I'll kind of leave that to you. Oh, one more page. Oh yeah, that's my favorite. This one, the last problem. This is the aspirin tablet problem. Okay? And it's really not, I make it look harder than it really is maybe. But if you read it a few times, the first paragraph kind of sets the stage. So I'm into doodling, so basically I pull numbers out of the first paragraph. Okay, you can see they introduce a new mass. You're like, grains, right? 15 grains is equal to 1.0 grams. Too bad they both start with the letter G. So GR is grains, G is grams. Okay, so I wrote that down. I go get my cup of coffee. And then I read the paragraph again. It talks about an aspirin tablet. So here's my little tablet for my hints. It tells me some things about the tablet. It says that that tablet contains 5.0 grains of aspirin is equal to 1 tablet. Okay. And then it goes on to say the last sentence in the description is a 155-pound individual takes 2 aspirin tablets per day. So I put here 155-pound body weight, that's the person's body weight, equals 2 tablets equals for 1 day. So that's kind of setting the stage. And then A specifically says what quantity of aspirin in 2 tablets, what is the quantity of aspirin in 2 tablets expressed in milligrams? So here's my kind of doodling for that. Tablets to grains, grains to grams, grams to milligrams. And sometimes there's more than one way to work this, definitely. B says what is the dosage rate in milligrams of aspirin per kilogram of body mass? this is where I went ahead and you kind of see in green, I looked back to what I had doodled earlier, and the 155-pound person is taking 2 tablets. Okay, so I use that to my benefit to kind of get started. And then the last one, C, at the given rate of consumption of aspirin tablets, how many days would it take to consume 1.0 kilograms of aspirin? So this one, can you see where the only number they give you is 1.0 kilograms of aspirin? That's probably going to be my first number. Okay, so actually it is. If I go ahead and go from the kilograms of aspirin to grams of aspirin, then I can go to grains of aspirin, okay, and then I can go to how many tablets that is. Okay, now to go from tablets to days, I recognize that 1 day is equal to 2 tablets. So again, you don't have to work it this way, but it's a thought. Okay, now what I want to do and what we're going to do are 2 different things. No, I'm just kidding. I want to go ahead and skip this section and go on to part 5 right quick. And just do the first few slides of part 5. Maybe. It's like the first 6 slides. Who's counting? There it is, okay. So this is right up the alley of what you guys did in lab on Thursday, okay? We're going to just talk about density for now, and then we'll talk about weight percent on Monday. On Monday, we'll go back and pick up the end of part 4 and the end of part 5, okay? So density, we said, is basically you take something like you did with your stopper or your block, you get the mass of it one way or the other, and you get the volume of it, and you take the mass divided by the volume, all right? And so units are grams or mass per volume. So actually, just with the units, you see how just like with speed, we could go back and forth between distance and time. With density, we can go back and forth between mass and volume. That's it. Same sort of deal. Okay, so we're actually just going to jump right in there. And this is one of your calculations that for your lab. Okay, can't remember which one it was. Maybe calculation 4. I'm not sure. So it's not water. It's methanol or methyl alcohol, and the density is given. It's less than dense than water, isn't it? Water at 4 degrees is well, that's 4 degrees Celsius, 20 degrees Celsius. But anyway, it's less dense than water. Okay, so 2 questions we are going to knock out right here, right now, is first off, we're going to go from volume to mass. Okay, what is the mass of 242 milliliters of methanol? We're going to have to use that density that's given to achieve that, to work that problem. So it's a volume to mass. The other one is a mass to volume. What is the volume of 50.0 grams of alcohol? Again, we're going to use the density. So this is about unpacking density. All of these are unpacking density, kind of like we unpacked speed with the loon that's flying very, very fast. Okay. And so I really encourage you to unpack things that you're going to use in your problem. To me, if you unpack them, they look more like puzzle pieces. And you know how if you are putting a puzzle together, you have to move that puzzle piece just right to use it. So these are all fair game. Physical property for methanol at the temperature specified, so 20 degrees Celsius. Okay? So the first one, solutions, that makes me laugh because they're like solutions, get it, yeah. Okay, so the first term is going to be the volume over 1. I know there's no over 1 here, but I usually would. 242 milliliters over 1. So we want milliliters to cancel, so do you see where we're going to put units of grams in the top and units of milliliters in the bottom? So this is the unflipped version of density. 0.792 grams over 1 milliliter. So milliliters cancel, we're left with grams. And we're done. Round it to 3 sig figs. 192 grams. Boy, after doing some of those other ones, that's a piece of cake. You're done.
It's the hardest one.
All right. So the next one, we're going to go from 50.0 grams to milliliters. And so the first term is going to be that 50.0 grams over 1. Now we want grams to cancel, so we have to put units of grams in the denominator. So this one's going to be 1 milliliter over 0.792 grams. Then grams cancel, we're left with units of milliliters. Does everybody think 3? See 3 sig figs? And you're done. 63.1 milliliters. That's the answer. Any questions about that one? So what I did was, at the end of this part, there actually is an assignment slide. And there are 2 questions on that assignment slide, 55 and 56. So I'm going to go ahead and assign those now. Those will also be due on Monday. We'll take a look at them, but they're just relatively straightforward density problems. So any questions? 155 and 156 will be due on Monday. Kind of pulling them out of sequence. Okay, so we'll take a look at those. Maybe. Okay, so here they are, 155 and 156. So chapter 1, question 55 looks like this. A block of iron, and it gives you the density of the block of iron. It's pretty darn dense, 7.86 grams. Yeah. And volume is given in centimeters cubed or cubic centimeters. Okay, and then they give you the dimensions of the block, its length, its width, and its height. Okay, and you're supposed to knock out the mass. So this is what a volume to mass problem. Okay, so the only catch here is to calculate the volume ahead of time, length times width times height. Okay, then you can use that volume in centimeters cubed, and then just basically plug in the density of iron. Centimeters cubed will cancel, and you're left with units of grams. You're done. The next one is kind of similar, very similar. Okay. Again, you're given the density, but the shape of this object is a cylinder. So actually, in the back of your Petrucci book, it tells you how do you calculate the volume of a cylinder. It's base times height, and the base is the area of a circle, which is pi r squared, and then times height. Okay, so those 2 dimensions are given. So you knock out the volume, and then again, it's like just like this. Once you have the volume, it will be in cubic centimeters again. Okay, and then you pull in its density, which is 7.75 grams per cubic centimeter, and come up with grams. Okay, that's all I got.